Why today is slightly shorter. Earth's rotation explained. Brace yourself. Today could vanish a tiny fraction of a second sooner than you'd ever imagine. And that seemingly insignificant slip has scientists and timekeepers on high alert. But here's where it gets controversial. If your afternoon feels like it's speeding by, the culprit is our restless planet. A team of experts who monitor Earth's rotation has forecast that on July 22nd, the planet will complete its spin about 1 millisecond faster than the usual 24 hours. That might sound negligible, but it has set off headlines calling it a freakishly short day, and left many scratching their heads. How do we even measure something so precise? For more than a century, astronomers have known that the length of our day isn't fixed. Tiny nudges from shifting winds, ocean tides, and even the swirling liquid iron deep inside Earth's core can tweak the spin by fractions of a second. Today, agencies like the International Earth Rotation and Reference System Service, IRS, combine data from radio telescopes aimed at distant quasars, super bright galactic centers so far away they appear motionless, with signals from GPS satellites. That information gets distilled into predictions of exactly how long each day will last. And this is the part most people miss. The same forces that sometimes speed up Earth's spin can also slow it down. Over millions of years, our planet gradually decelerates, thanks mainly to the moon. Its gravity pulls on Earth's oceans, creating tides, and the friction of moving water against the seafloor acts like a brake, a phenomenon called tidal braking. The result is a very, very gradual lengthening of days over geological timescales. Yet in recent years, researchers have noticed a curious cluster of days that were just a hair shorter than normal. On July 9th, for instance, Earth's whiplash-fast rotation trimmed about 1.4 milliseconds off the day. And on July 5th, 2024, the clock ran 1.65 milliseconds fast, the shortest day scientists have recorded since atomic clocks began keeping ultra-precise time back in the 1950s. We've known about these little variations for a long time, says Dennis McCarthy, former director of time at the US Naval Observatory and author of the definitive book on Earth's spin. They're part of the planet's natural behavior. Still, the buzz around recent short days has grown into a minor frenzy. Historically, when Earth rotation slows too much, timekeepers have added an extra second, known as a lead second, to keep our atomic clocks in sync. The last of these was inserted in 2016. But now that our planet has paused its gradual slowdown and even picked up speed on occasion, some have floated the idea of a negative leap second, actually removing 1 second from our official time. That idea has never been tried before, and many experts, including MIT geophysicist Thomas Hewing, doubt it will ever happen. Yet you might wonder, why care about a millisecond? Believe it or not, our high-tech world relies on pinpoint timing for everything from guiding rockets to synchronizing financial markets to directing precision agriculture equipment. At the equator, Earth turns about 4 football fields length every second. So even tiny speed-ups or slowdowns can build up over weeks and throw sensitive systems off course. Scientists use a blend of Earth rotation records, weather data, and long-term climate models to forecast daily spin rates. The farther out those predictions stretch, the fuzzier they become. So keeping close tabs on each day's actual rotation remains essential. And here's a twist that many find unsettling. Humans are now influencing the clock. As polar ice melts due to climate change, vast volumes of water flow downhill toward the equator. That movement redistributes Earth's mass outward, which, much like an ice skater extending her arms, slows the planet's spin. One recent study suggests that in a worst-case scenario, human-driven melting could eventually lengthen days by multiple milliseconds. If that happens, people, not the moon, would become the dominant force controlling how long our days last. That revelation raises thorny questions. Should we overhaul our timekeeping standards? Do we dare remove a leak second, undoing decades of practice? And are we prepared for the idea that climate change might not only warm our planet, but rewrite the very definition of a day? Now it's your turn. Do you think we should rethink how we define and measure time? Would a negative leap second cause more harm than good? Share your thoughts below. Do you agree with the experts who say these tiny shifts are a footnote in science? Or do you believe we're on the cusp of a timekeeping revolution? Let the debate begin. Why is Earth spinning faster in 2025? The race against time and negative leap seconds explained. Imagine a world where time itself is speeding up and scientists are on the brink of making a groundbreaking adjustment. The Earth's rotation is accelerating to the point where global timekeepers are contemplating an unprecedented move, introducing a negative leap second. This year, July 9 and July 22nd were unusually brief, shaving off approximately 1.3 and 1.4 milliseconds respectively. But hold on to your clocks, because August 5th is projected to be even shorter, losing around 1.5 milliseconds according to timeanddate.com. This isn't a one-off occurrence. Since 2020, Earth days have been getting incrementally shorter. Dirk Peister, head of Time Dissemination Group 4.42 at Germany's National Meteorology Institute, noted, "We now have slightly shorter days than in the last 50 years. Why the sudden speed up? A day on Earth typically lasts 86,400 seconds or 24 hours, which is the time it takes for the planet to complete one full rotation on its axis. However, this duration can vary due to factors like the positions of the Sun and Moon and Earth's gravitational field. On August 5th, the Moon will be at its farthest point from the equator, altering its gravitational influence and in this instance, accelerating Earth's rotation. Over billions of years, Earth's rotation has been slowing down, largely due to the Moon's gradual drift away from us. But since 2020, the planet has picked up speed, albeit by just a few milliseconds. These milliseconds might seem negligible to us, but they're critical for computers, GPS systems, banking, large telescopes, and global electricity networks that depend on precise synchronization. These systems are aligned with Coordinated Universal Time, UTC, which is based on over 400 atomic clocks worldwide, measuring time down to nanoseconds. UTC remains largely independent of day length due to Earth's rotational irregularities. Usually, these rotational variations balance out, but over time, they accumulate. When this happens, the International Earth Rotation and Reference Rotation System Service, IERS, steps in to add a leap second to keep everything in sync. But what is a leap second? Similar to leap years, leap seconds adjust for the discrepancies between astronomical time, based on Earth's rotation, and UTC, based on atomic clocks. Introduced in 1972, leap seconds have been added as needed. However, advancements in technology have exposed the problems they can cause, particularly in synchronizing precise instruments and computers. Patrizia Tavella, director of the International Bureau of Weights and Measures, BIPM's Time Department, highlighted that leap seconds often lead to failures and anomalies in computing systems. For instance, the aviation industry, which relies on accurate timekeeping for flight scheduling, has faced issues due to differing methods of adding leap seconds across various competing networks. In response, an international group of scientists and government agencies voted in 2022 to phase out the leap second by 2035. Now, with Earth spinning faster, the question arises, do we need a negative leap second? This would involve removing a second from UTC if astronomical time gets ahead of atomic time. Judah Levine, a fellow at the National Institute of Standards and Technology, NIST, and a physics professor at the University of Colorado, cautions that introducing a negative leap second could exacerbate existing issues with the leap second system. The primary concern about a negative leap second is that it has never been done before, and the software needed to implement it has never been tested, Levine explained. Darrell Veach, a professor at the University of Technology specializing in computer networking, echoed this sentiment, noting the challenges and risks associated with even positive leap seconds. So, will we see a negative leap second by 2035? Levine estimates a 30% chance within the next decade. This likelihood depends on various factors, including the potential abolition of the leap second and the impact of climate change on Earth's rotation. While recent years have shown an acceleration, climate change could slow it down due to melting ice altering water distribution. Veach added that the long-term trend is for Earth's rotation to slow down, but the current acceleration could persist for an indeterminate period, influenced by climate change dynamics. But here's where it gets controversial. Should we tamper with time to accommodate these changes, or let nature take its course?
What are your thoughts? Join the discussion below.
Earth's second shortest day ever, July 22nd, 2025. Why Earth is spinning faster. Mark your calendars. July 22 is set to be the second shortest day of the year, according to scientists. On this day, Earth will complete its rotation in a time frame that is slightly shorter than the usual 24 hours. Specifically, it will be 1.34 milliseconds less than the standard duration, as reported by timeanddate.com. When we think about the shortest day of the year in the Northern Hemisphere, we often refer to December the 21st or 22nd, which aligns with the winter solstice. Conversely, in the Southern Hemisphere, this occurs around July the 21st or 22nd, marking the time when that hemisphere is tilted the farthest from the sun. However, it's important to note that during these solstices, the change primarily affects the number of daylight hours rather than the actual time it takes for Earth to rotate on its axis. The intriguing 1.34 millisecond difference in the length of Tuesday is attributed to variations in the gravitational forces between Earth and the Moon. This gravitational interaction causes Earth to rotate a slightly faster pace, as explained by the Lunar and Planetary Institute. In recent years, Earth has consistently set new records for its rotation speed. For instance, on July the 5th, 2024, Earth experienced its shortest day ever recorded, completing a full rotation 1.66 milliseconds quicker than usual. This year, July the 10th also marked a notable event, being recorded as the shortest day of the year with a rotation that was 1.36 milliseconds faster than the norm. Looking ahead, August the 5th is anticipated to be the third shortest day, projected to be 1.25 milliseconds shorter than the average. Typically, Earth takes about 24 hours or approximately 86,400 seconds to complete one full rotation, with minor variations of a millisecond or so. Prior to 2020, the shortest recorded day was merely 1.05 milliseconds shorter than the average. If these trends persist, we may soon need to adjust atomic clocks by subtracting a full second to account for what is known as a negative leap second. The concept of leap seconds was introduced in the 1970s. While there have been numerous instances of positive leap seconds, where an additional second is added, there has yet to be a negative leap second. The International Earth Rotation and Reference System Service is responsible for monitoring the Earth's rotation and deciding whether to add or subtract seconds. In its formative years, approximately 4.5 billion years ago, Earth rotated at a significantly faster rate, with a full rotation taking only between 3 to 6 hours. During the mid-Proterozoic era, which spanned from 2.5 billion to 543 million years ago, the length of a day extended to about 19 hours, as noted in a 2023 study published in Nature Geoscience. Over time, the duration of a day has gradually increased to the current 24 hours. This change is largely due to the moon's gravitational influence, which steals some of the energy that Earth utilizes for its rotation, in addition to creating tidal friction. Moreover, climate change is contributing to longer days on Earth. Research published in the Proceedings of the National Academy of Sciences indicates that the melting of polar ice is affecting the length of a day. As ice melts, the redistribution of mass from rising sea levels is also extending the duration of a day. What do you think about these fascinating changes in Earth's rotation? Are we on the brink of needing to adjust our clocks significantly? Share your thoughts in the comments.